Hello, my dear students. Very good morning. Welcome to the Shortcutmaster, all of you. So today I am here with you regarding discussion of the concept of sign conventions for shear force and bending moment diagrams, all of you. Okay. So many students are getting confused regarding the sign conventions. So moving from right side to left side, moving from left side to right side, what is positive and what is negative, what is sign bending moment and what is Hawking bending moment, all of you. Okay, so within 5 to 10 minutes, I will definitely clear the entire sign conventions for you. You should have some patience. Okay, all of you. First of all, before going to an example, let me say the sign conventions while moving from right to left and left to right. Okay, so first of all, I'm just writing the things for the shear force diagram. Shear force, I'm saying, all of you. So for the shear force, that is SEF. Okay, for SEF, while moving from right to left, means I'm showing an arrow here like this. While moving from right to left, all of you. Okay, one second. Yes, while moving from right to left. Okay, all of you, that is while moving from right to left, the upward force, one second. Okay, the upward force is always taken as negative. I am saying about shear force. I am discussing about shear force diagrams for some beams. It can be any type of the load. It can be UDL, uniformly varying load. It can be point load. It can be any type of the load. Okay, if the same force is acting downward, then this should be definitely taken as positive. That is the case. Okay, all of you. Again, I'm repeating. While moving from left to right, while moving from right to left, I'm writing here. This is right side of the beam, and this left side of the beam, for example. While moving from right to left, upward is taken as negative and downward is taken as positive. Okay, and for example, I'm just going for the same shear force. Now I am moving from left to right of the beam. Okay, I am moving from left to the right of the beam, all of you. While moving from left to right of the beam, I can see, all of you, that the upward force should be always taken as positive as usual. Okay, as we're learning the sign conventions in the engineering mechanics, all of you. In the engineering mechanics, generally, while writing the equations of equilibrium, you are writing upward force as positive and downward force negative. Okay, general case I'm saying, all of you. Now, if you have a downward force while moving from left to right, it should be definitely taken as negative, all of you. Okay, so these are the perfect and the exact sign conventions for the shear force diagram. It can be any type of the beam, having any type of the load, having combination of the loads, all of you. So please note on all these things. Okay, now I'm going for the bending moment diagram sign conventions, all of you. Okay, so if you go for the bending moment diagram, I'm marking here, all of you. Okay, so while moving from right to left, that is in this direction to in this direction. Okay, look, in this case, while moving from right to left, the clockwise bending moment is always taken as negative and the anti-clockwise bending moment is always taken as positive. I am saying about bending moment sign conventions. Practically also I will say. Theoretically I am saying no. Practically also I will say. It will take some time. But try to understand these things. Okay. Now, if the same bending moment diagram you are going for example. Okay. And now we are moving from what we can say, one second. This one is right to left. Okay, so for example, if you are moving from left to right, okay, so left to right, in that case, all of you, the clockwise moment is taken as positive and the anti-clockwise moment is taken as negative I am saying all of you. Are you following what I am trying to say? This is the picture. Okay, so these are the sign conventions for the shear force and then bending moment diagram. I will go for an example also. No need to worry. I will not leave you. I will go for an example also. No need to worry about that. Okay, now all of you just see here. Let us go for a simple example, that is simple example. I am having a beam like this. Okay. Now I am having two types of supports. That means I was going with a simply supported beam, all of you, having a load at the center, having a load at the midpoint. Okay, so let this point be A, this point be C, this point be B. Okay, load is W. Okay, can I say all of you that this will become definitely W by 2 and this will become definitely W by 2 or not? Because for a simply supported beam having a load at the midspan, load will be definitely equally shared at both the supports. Okay, now I know both the support reactions. For this body, I want to calculate the shear force and bending moment diagram. This video is about the sign conventions and the construction of the bending moment and shear force diagrams. Okay, now what about the movement of the diagram? So let us see all of you. First of all, let me clear whether we are constructing the diagram by considering the movement from left to right or right to left. Okay, so my suggestion, okay, anyway you can go for, my suggestion is I will be drawing all the coming diagrams in all the next coming classes. I will be drawing every diagram, everything, anything from right to left only. Just now I told, while moving from right to left, while moving from right to left, upward is taken as negative, downward is taken as positive. Okay, therefore tell me all of you, we are moving from point B to point A. Point B to point A. What means we are moving from right to left? That means upward force is taken as what? Negative. Therefore, what I am trying to do, is observe all of you. Just simply extend all these lines. 1, 2, this one is 3. Okay, all of you. Now, let this one be shear force diagram line. This one be a bending moment diagram line. Now, marking the points, all of you, actually is point A, point C, and this one is the point B we have. Okay, so at the point A, this force is acting upward. Therefore, definitely you will be getting a downward diagram, negative diagram. Therefore, this becomes a diagram. Downward. Okay, all of you. Therefore, what I am trying to do, the shear force at the point B is nothing but what? Minus W by 2. See, since it is acting upward, we should take it down. Minus should be taken. Okay. Now, coming to the point C. Okay. So, after coming to the point C, you can check all of you. After coming to the point C, since we are moving from point B to point C, we have to take the loading on this entire part. Started at B, coming to the point C. After coming to the point C, take this entire load from B to C. Okay, so calculating the point shear force at the point C, we have an upward load. It is nothing but acting upward minus W by 2. So plus it is W. So finally, you will be having the load, that is how much? All of you, is equal to plus W by 2 is the picture. Is the case. Now, what about the shear force at the point A, all of you? Let us see. Okay, so minus W by 2 plus W. Okay, so I am coming from B to A. I want to calculate it here. I am coming from B to A. At B, we have a load W by 2 upward, negative. W is acting downward, minus. Okay, downward means it should be taken as positive, plus W I am taking. Okay, so from point C to point A, there is no load at all. Therefore, this becomes plus W by 2 only. Shear force at the point A we can have. Simple. Now tell me, this shear force which is equal to W by 2, which is the same value plus W by 2 here or not? You can cross verify. If you calculate from right to left, the entire shear loading should be definitely equal to the shear force acting at the point A. Definitely. Okay. Now we shall draw that. We shall start drawing the diagram. All of it is acting downward and then remaining constant. That means from B to, that means between, or we can say between B and C there is no load at all. Therefore, there is no change in shear force diagram, all of you. But after coming to the point C, because of this W, the load has been changed. Changed from where to where? Minus W by 2 to plus W by 2. Because of this W, the load has been changed from minus W by 2 to what? Plus W by 2 over this one. Okay. And next what happens, tell me all of you. From point C to point A, there is no loading at all. No shear force at all. It remains constant. No change in that picture. Are you following what I am trying to say? This becomes the shear force diagram. What about the bending moment diagram, all of you? Bending moment diagram, very simple. So here it is the point A, point C. This one is the point B we have. Tell me, what is the bending moment value at the point B? 0. I'm calculating from where to where. I'm moving from right to left only. Right to left only. Right to left only. Okay. So while moving from right to left, okay. So at this point B, there is no distance. Therefore, bending moment is equal to 0. What is the meaning of moment or bending moment? Force into distance is called as bending moment. What is the bending moment at the point C? Tell me all of what is the bending moment value at the point C? Okay, so coming to the point C. Okay, so with respect to the point C, you can check all of you. With respect to the point C, this load is trying to rotate the body. This load is trying to bend the body in which direction? In the anti-clockwise direction. Anti-clockwise direction of it. Therefore, I can check. I can take it as anti-clockwise moment is taken as positive. Therefore, it becomes plus W by 2 into L by 2. Okay, into L by 2 is equal to how much we can take it as W into L by 4. Okay. This 100% positive. Because while moving from right to left, clockwise moment is taken as negative, anti-clockwise moment is taken as positive. Okay, next coming to the point A, bending moment at the point A, very simple. Okay, now we are going to calculate the bending moment at the point A, write all the moments. With respect to A, W by T is providing anti-clockwise moment, W is providing a clockwise moment. That's it, all of you. Okay, that is a picture, all of you. Now, here I can just see like this. So, W by 2, load value, okay, multiplied by total distance is L, and since it is anti-clockwise, should be taken as positive, all of you, minus W into L by 2. It is clockwise, should be taken as negative, is equal to 0. Therefore, I can say at the bending moment, point A, at the point A, the bending moment is equal to 0. At the point B is becoming 0. Therefore, I can take it as a diagram like this. Okay, draw a line in this way, increasing and again decreasing. That's it. Therefore, this becomes the bending moment diagram. This becomes the shear force diagram. Okay, and this becomes the bending moment diagram. Okay, so I hope you are following, all of you. So my dear students, for more videos, please try to subscribe my channel, that is Shortcutmaster. Shortcutmaster, please don't forget to subscribe, all of you. And next thing is, what about the sign conventions of the bending moment? Clarity I want to just see. Okay, so here we have actually a simply supported beam. With respect to point C, this W/2 is trying to bend the beam in the anti-clockwise direction like this. In the anti-clockwise direction like this. Therefore, definitely tell me all of you, this becomes the bending shape or not? It's trying to bend in this way. And with respect to point C, W/2 reaction force is trying to bend the body in this direction clockwise. Therefore, this becomes the shape of, definitely I can say. Okay, therefore the very important point all of you, this becomes the moment direction and this becomes the moment direction all of you. Okay, and this is always called as the positive sign, and this is always called as the sagging bending moment, or simply called as sagging moment. Sagging moment can be always taken as positive. What about negative bending moment? Very simple. If you want to go for the negative bending moment, very simple. Let's go for a simple example for the what? For the cantilever beam all of you. Very simple. Very simple. Okay. Now I am having some load. Very simple diagram. I am discussing about bending moment diagram only because shear force is almost over W. And with respect to this point A, what the load W can do? The load W can definitely bend the beam in this direction like this. Am I right? This is the case. Are you following on? Perfect. This is the case. You can just take in this. Perfect. Okay. And since W is trying to rotate the body in the clockwise direction or bend the body in the clockwise direction, what the support will do? The support will definitely provide an anti-clockwise bending moment. Okay, onto the beam or not? Nothing but the moment here. Therefore, what happens, in this case, if this is the straight line, what happens, this will definitely become the bending moment diagram. Check out. Okay. Like this. Okay, where this will be your sign convention of you. 100% this will be negative. If you are moving from in this way, this will become definite. And this is 100%. 100% called as what? 100% called as what? Nothing but the hogging moment. That is the picture. Okay, all of you. So I hope you understand all the sign conventions clearly, all of you. Okay, now in this video we are drawing both the diagrams, shear force and bending moment diagrams, from where to where? From right to left. Next coming video I will draw the diagram from left to right also. No need to worry about that. I will, in next coming classes, I will make more videos about the sign conventions, about all the loads, and all the diagrams will be definitely covered. So your duty is definitely subscribe to my channel, that is Shortcut Master. Thank you. Have a nice day.